Our mission at Atlassian is to unleash the potential of every team, and we're proud to partner with public sector leaders who are shaping the future of government and education. We're here today to explore the frontiers of deep tech. Now, those breakthrough technologies that are redlining what's possible in government, education, and in industry. As we all know, adopting the latest technology can be difficult, and it can be challenging in any type of space that you're in. And we need to balance innovation and security. But the organizations that do this well, they see more benefit and success. Atlassian partnered very closely with the state of Utah to accelerate digital transformation and workforce modernization, helping address challenges such as rapid retiring workforce, attracting and retaining new talent, and including rural and remote workers, and developing faster, more secure, and more transparent services to your citizens. In 2018, Utah launched a bold telework and digital transformation initiative aiming to fully exit data centers by 2025. And when the pandemic hit, that urgency for cloud infrastructure skyrocketed. With Atlassian's cloud platform, Utah completed this 2.5 years ahead of schedule. Not only did they do that, but they enabled a secure remote workforce. They broke down agency silos, reduced IT change review times from 2 weeks to 24 hours. That's really unheard of when it comes to the government space. We are really excited with Atlassian's role with Utah as a testament as to what the power and what's possible when it comes to technology and when it comes to the vision of our leaders here. But the challenges ahead, like AI, cybersecurity, quantum computing, next-gen infrastructure, they require deeper collaboration and even bolder thinking. That's why I'm excited today to introduce Deep Tech, this Deep Tech panel featuring leaders who are pushing the boundaries of what's truly possible. Now, while today's discussion is not about Atlassian, it's about the spirit of innovation and transformation that we all share. These panelists bring expertise from areas across deep tech landscape spanning academia, industry, and public service. Together, they'll explore how emerging technologies can help us solve for more pressing challenges and create new opportunities for Utah and beyond. Thank you all for allowing me to set the stage.
Thank you for that introduction. I don't know if all of you are aware, but Atlassian just made a $1 billion acquisition in the state of Utah. So love having them be involved in our ecosystem. So I'm Angela Smith. I'm the COO of the Nucleus Institute. Nucleus is one of the hosts and sponsors of this AI panel. We're responsible for helping support and further the innovation economy here in Utah. And one thing that we do as part of the Institute is we have a $40 million fund that invests in deep technology, especially technology coming out of our universities and that are going through that commercialization journey. And there's not a lot of venture capital dollars that flow into early stage deep tech. And so that's one role that the Nucleus Institute plays. And so all three panelists up here are companies we have invested in or are probably going to invest in. And so we're really, really fortunate to have these people building and working in our state and doing incredible things. I set a career goal about 5 years ago to always be the dumbest person in the room. And the reason I set that career goal is I wanted to be around people who are smarter than me. And I'm really fortunate to have a job where that is true. I am definitely the dumbest person up here on this stage. These are incredibly smart people that I get to be around and work with every day, so I feel very lucky about that. So with that, let's hear about them and what they are working on. So we'll start with you, Masood.
Sure. Yeah. So I think whoever knows Angela knows that she is humble. She's humble and she's always like the best and smart. So thank you for bringing us all together. So my name is Masood Parwani. I'm the founder and president of Grid Elevated Energy startup company born in Utah. So we develop data aggregation and data collection and AI technology for the operation of the grid.
I'm Lexi Posse, so I'm the CEO and co-founder of Lucidity Sciences. I'm a mathematician by background, but I've been working in machine learning and data and analytics since about 2011. And, you know, through all of that experience in different industries, I saw there were a lot of limitations in the application of machine learning, both on the accuracy and the efficiency side, that, you know, as a mathematician, I was able to attribute to some fundamental algorithmic limitations. So what we at Lucidity Sciences have done is gone through and reworked the mathematical and algorithmic underpinnings of machine learning so that we're able to increase the accuracy and efficiency of these models simultaneously. And we operate in a number of verticals that have included finance, pharma, medicals, any way that there's a lot of data and a high need for accuracy and performance.
Thanks. Tim Miller, I'm the Chief Development Officer of Biologic Input-Output Systems, BIOS, as as the acronym goes. It's just like the BIOS for your computer, except what we've done is we've built a platform, a device that allows us to translate the language that the brain speaks with the body and do that in real time, in some cases even faster than human. You know, we're looking to use, and we are using AI to essentially make that even possible.
Really, really cool stuff that all three of these panelists are working on. So a little bit of personal information about me, but I have Crohn's disease, which is an autoimmune disease that is currently incurable. We don't have a cure for it. And I was at a doctor's appointment, and I was prescribed this new medicine. And my question was, how long am I going to have to be on this medicine? And my doctor's response was, until AI figures out a cure. And that was like a really interesting answer, but it was also very very exciting for me, because I was like, oh, there is the opportunity to find a cure. And that's one of the things that AI does. It brings possibilities that we didn't have before to solve really, really tough problems. So my first question for each of you is, we're all working on solving really tough problems that wasn't possible before AI. So talk to us about the problem that AI is enabling you to solve.
So one of the best quotes that I heard today was, AI is the next big invention after electricity. So funny, like we are this summarizes what we are doing in Grid Elevated, which is really bringing the power of AI to operate the grid more efficiently and more reliably. So the question is that, why do we need AI in the grid? So I think the grid, as you see, is everywhere. It's powering the livelihood of all of us, powering the houses, powering the business. But then the question is, what's wrong with the grid? Actually, there's nothing wrong with the grid. The grid is doing fine. So we are part of the grid that is called Western Interconnection. That is a large grid that spans through the whole Western U.S. and Canada, and that's one of the most reliable grids in the world. But then there are a lot of changes happening to the grid. So we are integrating a lot of uncertainty to the grid operation. The grid is getting older and older. Most of the equipment that we have in the grid is more than 50 years old. But on the other side, you see that we see more extreme weather events affecting the grid, from wildfire, heat waves, storms. But on the other side, we also are integrating new generation and also new loads. The data center integration on the grid is something that we didn't expect it's going to be a big boom 5 years ago. But then how AI is helping is really helping us to bring those data that exist on the grid and make sense of those data for the better operation of the grid. So in the past 100 years, the grid operators have done great by bringing electrons to us, right? But the reality is that in the past 20, 30 years, there has been bytes that come with electrons that carry very important information about what's happening in the grid, in terms of the observing the state of the grid. But the question is, how can we use those data in a way that helps us to be more resilient and more reliable and more efficient? That's what AI does for the grid, and that's what we are working on at Grid Elevated.
Yeah. That's great. My answer to the question is kind of maybe from an unusual perspective because the problems that we are solving are in AI itself. So when you look at some of the problems facing, artificial intelligence or machine learning, you can think about, what is the fundamental problem that machine learning or artificial intelligence is trying to solve? And the answer to that question in its, greatest generality is really it's trying to find patterns. And part of the question of that is, to what extent are you finding the real underlying patterns, and to what extent are you memorizing from the training data that you've been given? So if you and this is a vast oversimplification, but if you imagine the spectrum between a machine that memorizes all the things it's been seeing and kind of, fiddles with them a little bit to produce a better answer, versus finding the actual fundamental underlying pattern in the system, most of the existing algorithms are fairly naive in the way that they extrapolate from training data. The field's response to that reality has largely been get more data, right? Gather more data in terms of quantity, and we'll just encapsulate basically the whole world of possibilities in as much data as we can possibly gather, and then feed it through these very naive pattern synthesizers in order to produce a model that we then hope to learn from. We've taken a very different approach, right? So the other option than trying to just suck up all the data on anything that could possibly happen, which seems like a little bit of a stretch, is to innovate algorithmically to help the machines find patterns in smarter ways, right? So that they're actually picking up on the fundamental underlying patterns of the system. So that's the problem that we've been solving. And one of the side effects of that, so there's kind of two. One, the machine is more accurate in situations it hasn't seen before. But two, it's actually more efficient as well, because in finding the pattern, you're less reliant on memorizing a number of cases. So as an example, Amazon has this new tabular learning benchmark that they've put out. We are able to outperform the top performing models in the classification tasks, which took 500 hours to train on a cluster. We're able to do that in hours on a gaming laptop. So innovating algorithmically solves a lot of these foundational problems that then every application of machine learning or AI has to contend with down the line.
Excellent. So it seems almost like rhetorical at this point. If any of you have seen Empire Strikes Back, right? So, spoiler alert, Luke Skywalker loses an arm, right? Darth Vader cuts off his arm. And we're watching minutes later, he's got a brand new hand that can move in a perfectly lifelike way, touch and feel. And we all think, boy, that ought to be the way it is now. Like, isn't that all that technology, isn't it there? And the answer is no, it's not even close. If anyone knows someone that's got a prosthetic limb, bionic prosthetic limb, knows that there's a lot of dissatisfaction and things don't really work. So what we've done is we looked at that problem and realized, you've got thousands, if not tens of thousands of individual nerve cells in each of your body parts, right? And AI enables us to take all of that data and actually generate lifelike movement and generate, one of the coolest things is generate sensation back to your brain in a natural way, because we're using the exact same nerve cells back up to your brain. And so, with that technology, we're talking about, tens of thousands of megabytes a minute. Just huge amounts of data that are available. We're sampling these nerves at 30,000 times a second. Without AI, analysis of that would be impossible. Now, because the problem is not on the robotics. We all see these, Boston Dynamics robot dogs and humanoid robots that are doing backflips and running parkour, right? The problem's not on the robotics. The problem is in our ability to control them, and that's right where we've settled.
See, these guys are solving amazing problems. And so it's incredible to see the opportunity that comes with AI. I think a lot of this conference has been kind of balancing, the challenges that AI presents, but it's really exciting to see the major opportunities it's presenting and that you guys are all working on, really seizing and creating these incredible solutions. So Lexi, let's start with you. Every time I talk to Lexi, I'm just like blown away when she talks because I'm just like, I don't understand, but this is incredible. You have talked about how a lot of times we equate AI to LLMs, to large language models, and that kind of creates blind spots in how we think about AI. So can you kind of expand everyone's definition of what you see AI as and what maybe some blind spots are that you typically come across?
Yeah, absolutely. So I'll just start by saying that AI is an incredibly broad category, the definition of which has changed for decades, right? So I will not, in the time allotted to us on this stage, be able to provide a complete taxonomy and history of what AI has meant. But I think that when it comes to LLMs in particular, going back to this idea that what we're doing in AI and machine learning is finding patterns. These algorithms find patterns. In the case of an LLM, what did they find patterns in? They found patterns in language. So LLMs, or what we might call AI in the LLM form, is actually an application of these pattern recognizing algorithms to a very large corpus of language. And so when you think about trying to understand the world through the lens of an AI system, right? AI is supposed to tell us something new about the world that we can, learn from or discover or leverage in whichever way we want. You're sort of passing it through two filters that can warp the reality of the system. The first filter is algorithmic, right? That's where we work on innovating. But in the case of the LLM, the second filter is linguistic, right? There's a lot that happens in the world that doesn't have anything to do with the descriptions that we provide of what's happening in the world, right? Language evolved over the history of humanity to help us know where to find, a cluster of edible berries and communicate that to each other. It certainly didn't evolve to be able to fully encapsulate the nuance of the natural world around us and not even our, current financial system that we all operate in. So LLMs are a very particular application of artificial intelligence or machine learning that provides sort of an additional filter, which can be very helpful in many cases, right? The natural language interface is a great UI advancement that's available to us through LLMs. But there's so much more to the world and the structure of the world that we can leverage if we don't require ourselves to pass through the filter of language and can instead pass directly through the filter of math and data.
Amazing. We could have you go for a long time and give us a whole taxonomy on AI.
I won't.
Masoud, you have a huge vision. The name of his company is Grid Modernization. And literally what you're trying to do is modernize our entire grid system. So can you kind of talk to us about how you're utilizing AI to do that and kind of what are the barriers you're having to overcome to fulfill this vision?
So again, the grid is great. The grid is doing fine, but there's always a but, right? So what's happening is that you look at the grid. It's like what we are doing with the cars right now, right? So we have cars. They are doing fine. We are driving them. But on the other side, I have a Tesla. I have FSD, and it's driving so good by itself from A to B with no interruption. So the question is that, what's going to happen to the grid with all these changes that is happening to the grid? So that's our vision, is a self-operating grid that really doesn't take the human out of the loop, but minimizes the interaction and uses the data and AI models to operate the grid through ups and downs, through interruptions, through changes and through uncertainties without impacting the customers, because that's what we rely on. We rely on a reliable power to be able to basically do anything in our life, right? We need power. So that's our vision for the grid. And so what AI is doing as you lectured very very accurately. You should be a professor, by the way. So like, yeah, I know. So I think so. What we are doing, we are really looking at like first thing for AI, how the data that exists in power utilities can come together in one platform. So you visit any utility these days, like larger, smaller, municipal, rural. There are a lot of data. Almost any equipment you have in the power grid comes with a lot of data. But then when you go to operating room, you see an operator sitting behind like 5 monitors at least. In each monitor, there's like 5 different windows open. In each of them, there is a data that comes in, but none of them are in one platform, none of them are interoperable together, and none of them are talking together. But then that makes impossible like to use any AI model, to use any control model, to use any algorithm basically, because they are not in the same place to start with, right? So that's the first thing we did with Ingrid. We developed what we call a Power Grid AI console, that we call it Midas. And Midas, what it does, it brings all the data together, all the data in operating room, in a power grid operator, together in one platform in a way that actually you can now make sense of it. You can use it for operation. Then we enables like a lot of algorithms, from as simple as a machine learning algorithm for load forecasting, price forecasting, to as complex as a like deep reinforcement learning algorithm that is like making feasible decisions based on the physics of the grid to make sure that like the grid is operating in a way without necessarily human interaction and human intervention coming, making a decision, reading Excel sheet to do that. So that's kind of what we are doing and is our vision for the grid. But on the other side, there are of course challenges. So it's just like bringing to some of this data together in one platform is not easy, right? Convincing some of these operators, convincing some of the decision makers that AI is good. You can trust an algorithm to make a decision for you, and that's not easy. There are regulatory barriers, of course, but I think what we are doing in Utah is great. There is always like a kind of a mindset of innovation. We are making risks on like being the first on using a technology. For example, in one of our first partners is a small utility you probably know is called Heber Power and Light. They operate the power grid of Heber City and Midway, and what they do, they were our first client. They took the risk of like accepting a new technology. There is always a risk in using the first and being the first user of a technology, but they are also getting the advantage and getting the benefit of that. They are serving up to a tune of 15 to 20% in operating cost on a real-time basis every day, and that's where it's coming from, the operation, from using and trusting a technology that wasn't used anywhere else. But then they are our first client, but that's also happening in Utah. There's we are going to talk about ecosystem next, but then that's really like what we do in Utah, really innovating and also taking the risk to use that innovation.
We are so grateful to have you in our ecosystem solving this huge problem, because we know AI is only going to cause a lot more energy issues for us. Tim, your company has a really interesting combination of hard tech. So you actually are manufacturing and working with hard tech, and then combining that with software, which a lot more companies that, at least that I'm seeing, are needing to combine hard tech and software. So can you talk about how AI has helped enable, and you've kind of alluded to this, but go a little bit more into detail of how AI has enabled the ability to do that?
Yeah, you bet. It's, I mean, it comes down to that problem you're solving in the first place. And, what the AI tools have allowed us to do is actually take advantage of the hardware that's out there. You'd be amazed at the microcontroller capabilities that are out there in the hardware realm today for edge computing, right? So AI happening at the location, right? The last thing we want is someone that's operating a robotic arm or leg or an exoskeleton, and they've got to be connected to the internet for it to work, right? So so it's really a combination of bringing all those pieces together, which is not an easy task. And so with the AI tools, we're actually using it to accelerate our development cycles. Or we're using it to help with printed circuit board design. We're taking advantage of many of the tools as we can to make this pulling together essentially 6 different technical disciplines into one product, capable and affordable, so that we don't go out of business.
And Tim, I'm going to start with you here. Our last question for all of the panelists. I think this is going to be a pretty easy one for you to answer, but the theme of this summit is pro-human AI. So how do you, what does that mean to you, and how is your solution helping enable
Yeah, that
the
is an easy
humanness of
one.
AI?
I can sum it up in one participant, this was several years ago, had a robotic hand attached that had sensors in the fingers and in the hands. He was able to hold his wife's hand and actually feel her touch through a robotic hand. And I can tell you, everyone in the room just waterworks. It's Dr. Greg Clark up at the University of Utah is retired now, but he says losing a limb is akin to losing a loved one, except that you're reminded about it every single day. And there's real problems out there to solve. Which is why we got into this business, because we're not just talking, amputees. It's anywhere where you've got, you can have chronic pain, neuropathy, just a huge host of medical conditions where, our goal is to alleviate suffering, and to make disabilities no longer a disadvantage.
Incredible. Thank you. Lexi, how would you answer that?
Yeah, I love your comment on there are real problems out there to solve. And I think that's been something that, I've been very guided by as well. One of our first case studies was brought to us by a 20-year ICU nurse who basically said, we have this clinical indicator, but it's not helpful for us in the ICU because it's predicting everybody's at risk, right? So it's risk of a particular type of injury. There's limited resources and time in an ICU, right? Limited sort of specialized beds to help prevent injuries from occurring. And so it was this very pragmatic logistics problem of, how do you increase the precision of a prediction so that you're able to serve the highest risk populations with limited resources? And I think that was just such a pragmatically grounded problem. And for me as a mathematician who's been spending a long time thinking about sort of the most abstract structure of problems, to be able to tie that to, human suffering and alleviating it and provider quality of life was something that was incredibly rewarding, and not something I got to experience, just sitting down and working through the calculations.
Yeah, there's nothing quite like it, right? When you see the impact it can have on someone's life.
Exactly. And, I having grounded that, I also want to kind of give a little bit of a higher level answer as well, which is that when it comes to humans and AI, I think that we are selling ourselves short by focusing on trying to make AI that looks and acts and thinks like us, right? Machines are very good at things that humans are not very good at, and vice versa. And so if we can come up with design paradigms which allow machines to take us further in terms of insight than we would ever be able to go as humans, while also leveraging all of the expertise and the care that humans bring to their work, I think that's where the future of AI lies.
Amazing. Masood?
Yeah, I think that's very important. We think about it every day. So we have the critical infrastructure, power grid, and that's been in the hands of some of the most responsible people in the world, like the power grid operator. You can't imagine some of these people, VPs, operator, dispatchers. They always have a phone in hand. There's a power outage somewhere. They get the phone and they have to answer. And you need to make sure that the power is back to the customers, right? But then the question is that how can we rely on technology, AI, to take over that responsibility? That is again going to go back to be responsible in delivering a reliable power to the customers and to the people, right? So I think that's very important that we design a system that is going to deliver not only the same but a better quality of like services to the customers who are basically the users of the users of that power. On the other side, there are operators. I call them humans behind the grid, right? So like I think what we are doing, we are feeling the responsibility of making the job easier for those people who are responsible or who are under the pressure of like making sure the power is delivered responsibly. So I think so yeah, it's not probably as sensible as like losing a limb or like how pro-human it could be, but really like having a reliable infrastructure is really serving the human.
Yeah, tell that to the people in Houston 2 winters ago.
I know. Yeah, they felt it different.
Well, a huge round of applause for these incredibly intelligent people in Utah who are working on solving huge problems. Thank you so much. We have one more panel left. We had amazing content today, so our last panel coming up is kind of AI groundbreakers, like people who are really solving some really cool problems as well.